Alright, in this video we're going to begin to look at one of the ways that we can solve a system of equations. And that's by using a method called substitution. What we're really looking at here is solving systems algebraically. So with that in mind, a few little details. To solve a system algebraically, what we have to do is find a way to use the two equations that we're given, because again we're dealing with systems of two equations, to produce a new equation that has only one variable. Because if it has only one variable, we know how to solve that. So our goal becomes, what can we do to our equations to come up with an equation that has only one variable. And there's various methods, but both of them really kind of fall into one of two categories, and that's some form of substitution or some form of what we'll look at later called elimination. So, as an example, consider the equations x plus y equals 6 and x minus y equals 2. What we're going to detail here is the substitution method, which is one way that we make use of our two equations to produce a third equation that has only one variable that we can then proceed to solve. So here's how substitution works. Step 1 is to solve one of the equations for a variable. Now you have two equations there. Each of those equations have two variables. So you potentially have four different things that you could do. You potentially have four different things that you could do as you're solving, as you're deciding which variable to solve for. I'm going to say let's go ahead and solve the top equation for x. So x plus y equals 6. I want to solve that for x. So to solve for x, all I have to do is take and bring the y over to the other side. And so I get x equals 6 minus y. The second thing is now to take that result and substitute it into the other equation. See, we've already made use of the first equation. So to put that back into the first equation, then we'd only be using the one equation. We have to use both equations to be able to produce that third equation. So we've already used the first one to solve for x. Now we go to that other equation, x minus y equals 2, and we want to replace the x with what it's equal to there, the 6 minus y. So I just replace the x with 6 minus y, and now I notice I have an equation that has only one variable. Now that equation can be simplified a little bit. The parentheses can be dropped, combine like terms, you get 6 minus 2y equals 2. Well, now we have an equation that has only one variable. We know how to solve those. So the third step kind of follows very naturally. Solve the new equation. So we take that 6 minus 2y equals 2 and we solve it. To solve it, we need to get y by itself. So we subtract 6 from both sides. Get negative 2y equals negative 4. Divide by a negative 2, and now we have y equals 2. We know half of the answer now. So the final step is to figure out, well, what's the other half? Well, we have lots of equations relating x and y. So step 4 is to take that answer and plug it back in to find the other variable. Now again, we have lots of equations relating x and y. X plus y equals 6, we could put 2 in there. X minus y equals 2, we could put the 2 in there for y and solve for x. The easiest thing to do, though, is to plug it into the equation that's already been solved for x. Because then, all we have to do is we don't have to solve anymore. Right? It's already been solved for x, so we just have to do the arithmetic. So any pair of equations now relating x and y, we could plug that number into. The easiest one is to pick the equation that's already been solved. And so we do that, and you can see we get 4, 2, which is the same answer we got in a previous video when we solved this system by graphing. Okay, in upcoming videos we'll look at some more examples of using the substitution method. Until then,